Welcome, and thank you for joining this presentation on the Software Testing Lifecycle, or STLC. Over the course of the session, we'll explore the key stages involved in testing software to ensure it meets quality standards. You'll learn not just the basic steps, but also how modern agile practices and Scrum methodologies integrate with testing to make the process more efficient and responsive. This will include understanding the roles within a Scrum team, how testing fits into iterative development cycles, and the importance of continuous testing and improvement. By the end, you'll have a clear grasp of how to manage and execute testing activities effectively in today's fast-paced software development environment. Let's get started. When starting the testing phase, the first step is test planning, where we define the scope, approach, resources, and schedule. Next, we design clear and comprehensive test cases to cover the requirements. Setting up the test environment comes after, ensuring all necessary hardware, software, and configurations are ready to run tests accurately. Then, we prepare test data that simulates real-world scenarios to validate functionality. Once everything is set, we execute the tests and carefully observe the outcomes. Analyzing the test results helps us identify if the software meets expectations or if any issues persist. When defects are found, we report them in detail and track their status through resolution. Lastly, we compile reports summarizing all test activities to provide stakeholders with a clear picture of quality status. This process forms the foundation of the software testing lifecycle, ensuring thorough and efficient validation of software products. In agile environments, these steps integrate with iterative cycles and continuous feedback, facilitating regular improvement and adaptation. A software testing lifecycle involves several key phases, each with specific activities and deliverables that ensure a structured approach to testing. It begins with requirement analysis, where we review the software requirement specification, design documents, and other related materials to identify any defects early on. Next, test planning takes place, where, based on our analysis, we decide what needs to be tested and develop a detailed test plan, including estimates and schedules. Then comes test design, where we create test cases and prepare test data according to the requirements and scenarios identified. Setting up the test environment follows, involving the configuration of servers, clients, networks, and virtual environments to mimic the real user setup. After that, we execute the test cases to verify if the system behaves as expected, carefully documenting pass or fail outcomes along with any defects found. Finally, we prepare comprehensive test reports that summarize the execution results, current defect statuses, and daily progress, providing clear visibility into testing outcomes. This systematic approach ensures thorough validation and helps maintain high software quality throughout the development process. A test plan is essential because it acts like a roadmap for the testing process, clearly outlining what needs to be done and how. It helps us check if everything is feasible, including whether we have the right resources, whether the cost and schedule fit within our limits, and if the goals are realistic. Essentially, a test plan is a detailed document that describes the scope of testing, the approach we will take, the objectives we aim to achieve, and the resources and timeline involved. Having this plan in place ensures everyone understands the expectations and helps prevent delays or overspending during the project. In agile teams, for example, while the test plan may be flexible and evolve with each sprint, its core purpose to guide the testing effort clearly and efficiently remains the same. This makes testing more organized and supports continuous improvement as we adapt and respond to any challenges throughout development. Test plan begins with a clear introduction of the project, explaining its key objectives and why this test plan is important. It then defines the scope, outlining exactly what areas or features will be tested to ensure focus and avoid scope creep. Next, it lists the specific features and requirements that fall within this scope, helping the team understand what components are targeted for validation. Equally important are the features that will not be tested, which are identified to set the boundaries and manage expectations. Finally, the plan includes references to all the key documents and resources used to create the test plan, ensuring traceability and consistency. This structured approach helps streamline the testing process, supports clear communication among stakeholders, and sets the foundation for efficient test execution in line with agile practices. In defining our approach to testing, it's important to establish clear rules and processes upfront to guide all activities. The testing process itself covers everything needed to verify that the product works as intended, starting with documentation that outlines what needs to be tested and how. We begin by reviewing requirements and design documents to identify potential gaps or issues. This is followed by preparing and executing tests while carefully managing test data to simulate real scenarios. The types of testing involved range from unit tests, which focus on individual components, to smoke tests that quickly check basic functionality. Integration tests verify that different parts of the system work together smoothly, while functional tests ensure that features meet the specified requirements. Regression testing helps confirm that new changes don't break existing functionality, and system testing validates the entire product in an environment that mimics production. Employing this structured approach helps maintain quality throughout development and aligns well with agile practices, where continuous testing and feedback are key to delivering reliable software iteratively. In this section, we define the roles and responsibilities that support the activities outlined in our test plan. The tester plays a crucial role by identifying test scenarios, creating and reviewing test cases, and managing dependencies. They carry out various types of testing, including smoke, functional, and regression tests, and ensure all fixed defects are retested. Testers also track progress and report any issues to the project manager. The infrastructure or configuration management team provides essential deployment support to the development team, ensuring releases are smoothly handled. The test manager acts as the main link between the testing team and the customer, providing regular status updates and managing the release progress to ensure deadlines and quality standards are met consistently. They also facilitate communication between the support team and the client, ensuring that everyone stays aligned throughout the project. Together, these roles form a coordinated system that helps maintain transparency, accountability, and smooth execution of the testing process. The test team will hold weekly meetings to discuss the progress of testing and identify any dependencies that might impact the schedule. Each meeting will have a clear agenda focusing on the current status, any issues encountered, and next steps needed to keep testing on track. Action items will be assigned to specific team members to ensure accountability and timely resolution of problems. To track progress effectively, the test team lead will measure key metrics related to testing activities, such as test coverage, defect rates, and completion percentages, and prepare reports that reflect these insights. This structured approach to change control helps maintain clear communication, ensures that changes are managed efficiently, and supports continuous improvement throughout the test lifecycle. When developing test cases, it's essential to follow clear guidelines and use standardized templates to ensure consistency and traceability. These templates help capture all necessary details, like test objectives, steps, expected results, and data requirements. The approval process ensures that all test cases are reviewed and validated by relevant stakeholders before execution, reducing errors and gaps. Coverage guides help define the scope of testing to make sure all critical features and scenarios are included. For test execution, it's important to establish detailed procedures for setting up data and environments to replicate real-world conditions accurately. Capturing and tracking test results systematically is crucial. This involves logging outcomes, defects, and progress so that the testing status is transparent and actionable. Finally, defining clear entry and exit criteria guides when different types of testing can begin and satisfactorily conclude, which supports structured and efficient testing cycles. This approach aligns well with agile practices by promoting continuous feedback, clear accountability, and flexibility to adapt test cases as requirements evolve. In managing defects, any failure during a test case execution is recorded as a defect, and to handle these effectively, we need clear guidelines on defect management tools, defect levels, life cycle, and reporting. Defects are categorized by severity, starting with critical defects that completely block functionality and require immediate resolution, followed by high-priority defects that also hinder major processes but may be slightly less urgent. Medium-level defects represent deviations that don't severely impact the system and usually have workarounds, while low-level defects are mostly cosmetic or documentation issues. Understanding these categories helps prioritize fixes based on impact. Additionally, it's important to define assumptions, project schedules, changes, dependencies, and scope related to defects, as these factors influence how and when defects are addressed. Proper defect reporting and lifecycle management ensure that every defect is tracked from identification to resolution in a structured way, aligning with best practices in Agile and Scrum, where continuous feedback and quick iterations help maintain product quality throughout the development cycle. For effective testing, it's important to have the right resources in place. This starts with setting up the test environment according to the testing phase, ensuring it supports all test activities. We'll prepare a checklist to confirm that all hardware and software components are properly configured before testing begins. Selecting the appropriate testing tools is also crucial, as these should align with the type of testing being performed, whether functional, system, or unit testing. Staffing plans must identify who will participate in the testing team and when they will be involved, to maintain clear roles and responsibilities throughout the process. If necessary, training should be provided so everyone understands the tools, procedures, and objectives. For environments, we typically use Dev for unit testing, SIFT for functional system testing, and ST for system testing, each accessible via their respective URLs. This structured approach helps us manage resources effectively, keeping testing organized, efficient, and aligned with agile best practices like collaborative roles and iterative feedback. To determine pass or fail criteria during test execution, it's important first to set clear benchmarks that align with the project's goals. These criteria define what constitutes a successful test, typically based on meeting specific requirements or achieving certain levels of coverage without critical defects. Scheduling plays a key role here, so tasks and their completion timelines should be estimated realistically by considering the available budget and resources. For instance, tasks like finalizing the test plan, reviewing requirement documents, and creating test estimations all have target completion dates that help keep the process on track. Alongside scheduling, we must proactively identify risks, such as delays in component delivery, which can impact the overall testing timeline and potentially push back project delivery. To mitigate these risks, we might need to adjust schedules or modify the testing approach to maintain progress. By clearly defining these pass-fail criteria, mapping out schedules aligned with project constraints, and having contingency plans in place for risks, we create a structured and adaptable testing process that supports successful delivery. Throughout the software development lifecycle, the test deliverables are essential documents and artifacts shared with stakeholders to ensure transparency and alignment. These include the test plan, which outlines the overall approach and scope of testing, and the testing strategy that defines how testing will be executed. Test scripts detail the specific steps to carry out tests, supported by test data used during execution. The test traceability matrix connects requirements to test cases, helping verify full coverage. After running tests, test results and reports provide insights on the findings, while the test summary report offers a concise overview of the testing efforts and outcomes. Installation and configuration guides assist users in setting up the software, and defect reports track any issues found, including their status and resolution. Release notes communicate key changes and updates in the current build. The user manual supports end users by explaining how to use the product effectively. Finally, agreements and sign-off of the test plan formalize acceptance and confirm that all parties agree with the testing approach and results. This comprehensive set of deliverables supports quality assurance, aids communication, and ensures the product meets stakeholder expectations. When designing and executing test cases, it's essential to have a clear, structured approach that ensures thorough coverage and accurate results. Test case design involves defining specific conditions and steps that verify the functionality of the application, making sure every feature behaves as expected. Execution then follows these cases systematically, logging outcomes precisely and capturing any defects immediately. Good communication during this process is vital, as shown by the contact details provided, enabling quick resolution and collaboration. Visuals like the magnifying glass over the binary code highlight the focus on detailed inspection and precision, while the team building the puzzle represents how testing is a collaborative effort, piecing together different components to form a complete quality product. This combination of careful planning, execution, and teamwork ensures that testing not only finds defects, but also helps improve the overall product quality in line with agile principles, supporting iterative delivery and continuous improvement. We need to ensure several key functionalities are working as expected. First, the display feature on the welcome page should correctly show user information and relevant details. Logout functionality must work smoothly, allowing users to securely exit the application. Users should be able to view and print their ID cards without issues. Navigation using the quick links should take users to the correct pages quickly and effortlessly. The last login information displayed must reflect the current system date to maintain accuracy. Lastly, payment details, including the due date and the calculated payment amount, need to be correct and shown in the right place on the interface. Testing these scenarios thoroughly will help us confirm that the system meets user needs and operates reliably. When designing test cases, it's important to cover every aspect of the application's functionality systematically. Start by identifying all screens and their key elements like links, buttons, checkboxes, radio buttons, drop-down lists, tables, and text fields. Consider how users interact with these elements through actions such as sorting, saving, editing, deleting, or navigating, and ensure each action has corresponding test cases. Also include common functionalities like pop-ups, security features, access control, enabling or disabling options, and error or success messages to cover expected system responses. Don't forget to test procedures and triggers behind the scenes that automate responses, as well as forms and reports that capture or display data. Evaluating layout and design elements such as icons and titles helps verify the user interface is consistent and intuitive. Data handling deserves attention too. Test for correct data types, validation of inputs including blank or valid entries, auto-population versus manual entry, and how errors are logged. By structuring your test cases around these comprehensive categories, you can ensure thorough coverage of every functional and UI aspect, which aligns well with agile testing practices where continuous feedback and detailed verification are key. This structured approach also makes it easier to prioritize test efforts, adapt to changes in requirements, and maintain quality throughout iterative development cycles. In real-world testing, it's rarely possible to test every possible scenario exhaustively because of time and budget constraints. That's why error guessing is a valuable technique. It helps us focus on areas where defects are most likely to occur based on experience and intuition. Instead of randomly testing without direction, we design test cases guided by patterns or charts that highlight common error-prone spots, such as boundary conditions or input combinations that have caused problems before. This approach lets us efficiently uncover critical bugs without needing to try every possible case, keeping the testing process practical and targeted. It also aligns well with Agile Scrum practices, where we aim for continuous, incremental validation without overextending resources, prioritizing tests that deliver the most insight in each sprint. Equivalence partitioning is a testing technique used to reduce the number of test cases by grouping input data that should be treated the same way by the system. In this example, we're verifying the functionality of a teenager age input field. According to the rules, valid ages must be between 13 and 19, and the input length should not be 3 characters. Using equivalence partitioning, we divide the input into 3 groups: invalid ages from 0 to 12, valid ages from 13 to 19, and invalid ages from 20 to 999. The boundary value analysis focuses on testing the edges of these partitions, where errors are more likely to happen. For example, entering age 12 triggers a validation error because it falls just below the valid range. Designing test cases this way ensures we cover the critical boundaries efficiently without testing every single value. This approach helps streamline testing across all levels and supports agile delivery by prioritizing impactful test cases and reducing redundancy. State transition testing focuses on verifying how a system moves from one state to another based on specific inputs and events. It looks at the starting state, the input or event that triggers a change, the resulting output or action, and the final state after the transition. For example, consider a login screen. When a user enters the correct user ID and password, the system grants access. After completing activities, the user logs out and the application closes. Each of these steps represents a transition from one state to another, triggered by events like inputting credentials or clicking logout. Actions, such as displaying a success message or ending a session, result from these transitions. Sometimes transitions depend on conditions, like allowing only 3 login attempts before locking the account. This technique helps ensure that all possible state changes and their outcomes are tested thoroughly, which is especially useful in applications with clear state-dependent behaviors. Decision table testing helps us verify how different combinations of inputs lead to different outcomes in a system. For example, consider a flight booking scenario where the booking button is enabled only when certain user inputs match specific conditions. Here, the inputs include flight origin, flight date, destination, and return date. If all these inputs are present and valid, the booking button becomes active, allowing the user to proceed and view different flight details. However, if any of these inputs are missing or incorrect, the button stays disabled, and the system prompts the user with an error message to correct their selection. This approach ensures that every possible combination of inputs is tested against expected results, making the testing process thorough and systematic. Using decision tables like this aligns well with agile practices by helping teams define clear acceptance criteria and automate tests that cover multiple input scenarios efficiently. When designing test cases, it's important to base them on several key documents and inputs, such as the system requirement specification, data design specification, business rules, change requests, and use cases. First, identify all the functionalities of the system or component. Include positive test cases that cover expected behavior and negative test cases that check how the system handles errors or unexpected inputs. Be sure to capture any specific business rules that dictate how the system should operate. Also, consider any approved change requests to ensure new or modified functionality is tested. A risk-based approach helps by imagining potential failure points and designing tests to target those risks. Additionally, leverage your domain knowledge and previous experience to enhance the test design. When writing test cases, follow common principles. Keep them simple, transparent, and non-repetitive. aim for full coverage while ensuring they're cost-effective, make each test case identifiable and reusable, and, where possible, create test cases that can be automated. This structured approach helps ensure thorough and efficient testing focused on quality and reliability. A use case outlines the specific steps or actions that show how an actor, whether a person, an external system, or even something like time, interacts with the system to reach a particular goal. It breaks down these interactions transaction by transaction, starting from the beginning and continuing through to the end of the process. This approach helps testers design test cases that ensure the system behaves correctly in every step of a real-world scenario, providing complete coverage by following the actual flow users will experience. For example, looking at an ATM system, you can see how a customer interacts to check balances, deposit funds, withdraw cash, or transfer funds, while an ATM technician might perform maintenance or repairs. Each of these interactions represents a use case, and by testing them thoroughly, we make sure the system works reliably across all these different functions and user roles. Using use cases to guide testing aligns well with agile practices. We're ensuring that each user story or requirement is fully tested in the context of how it will be used in reality leads to higher quality and smoother deployment. In agile testing, the process begins with clear requirement gathering and careful planning, which sets the foundation for what needs to be tested and how. This step involves collaborating closely with the product owner and development team to understand the features and acceptance criteria. Once the requirements are defined, test cases are planned to align with the user stories and sprint goals. Testing then happens iteratively within each sprint, meaning that tests are continuously created, executed, and refined as the software evolves. After each iteration, the tested and validated features are deployed, allowing for quick feedback and adjustments. This cycle supports continuous integration and delivery, ensuring that quality is maintained throughout development while adapting to changes efficiently. By focusing on short iterations and frequent deployments, agile testing helps teams deliver valuable, working software regularly. A test case is a detailed set of steps, conditions, and expected results designed to verify a specific function within the software. It starts from a test scenario, such as checking whether a user can view and print their ID card. Before running the test, prerequisites like setting up the test environment, preparing test data, or confirming the URL must be met. Test data are inputs used to validate the requirements during testing. The test steps outline exactly how to perform the test, following a clear sequence to cover the functionality thoroughly. The expected result defines what should happen according to the functional requirements. After executing the test, you record the actual result and compare it to the expected one. This comparison helps determine the test status, which could be pass, fail, on hold, out of scope, or not applicable. Structuring test cases like this ensures consistency, traceability, and clarity in the testing process, supporting effective validation of software features. This is an example of a basic test case template that includes all key elements necessary to organize and track testing activities effectively. It starts with general project information like the project name, testing phase, release version, and functional area, along with complexity and dates for design, peer review, approval, execution, and completion. Preconditions and dependencies help clarify what setup is required before testing begins and what external factors may impact the test. The core section details the test scenario, including a unique ID, description, and detailed test steps. It specifies the expected results so testers know exactly what to verify. There are columns to document the test data used, steps taken during execution, actual results observed, and whether the test passed or failed. Finally, any defects found and comments provide room for feedback and tracking issues. This systematic approach ensures clarity, accountability, and comprehensive coverage when validating software functionality, which is essential in both traditional and agile testing environments. Test data is essential for verifying that the software meets its requirements and for successfully executing test cases. There are several methods to create test data, each suited to different testing needs. One approach is using scrambled production data, which helps maintain privacy while using realistic data. Another way involves developing data specifically based on the application's functionality to ensure all possible scenarios are covered. Sometimes data is provided directly by business analysts or customers, usually reflecting real-world use cases. Testers may also create specific data tailored to test edge cases or unusual conditions, and legacy data from previous versions of the software can be reused to validate ongoing functionality. Understanding these different test data creation methods helps improve test coverage and the reliability of the testing process, especially when aligned with agile practices, where continuous and iterative testing is fundamental. Thank you for taking the time to watch this presentation. If you have any questions or need further information, feel free to reach out via the email or phone number provided. I hope the insights shared on use cases, agile testing processes, test case design, and test data creation will help you improve your testing approach and deliver better software quality. Remember, effective communication and clear documentation are key to successful testing and collaboration within agile teams.